In the previous video, we saw how easy it is to connect an external oscilloscope to ngscopeclient. And today we'll do something a bit more useful, which is using it to acquire three signals in this case and do a bit of data transformation and send it to an SPI decoder, where we can see the signals, the clock, and how it translates to some X values. So let me start from the beginning. So we have this microcontroller that came with this nice frequency generator, LMX2595, that in theory does up to 20 gigahertz. Pretty cool. So this microcontroller has a little screen on the other side and talks to this frequency generator through this group of wires over here, through SPI protocol. And I'm connecting three wires. So we would need four in order to get all the pins used in this SPI communication. But in this case, I'm just interested in the information that goes from the microcontroller to the chip. So I just need three wires, which is clock, data, and chip select. And right now I have this connected to my oscilloscope, and it's going to be a good test when we compare this information with ngscopeclient to see if the data is similar. So we have something to test against to make sure that we're doing this SPI reading correctly. Let me show you the configuration that I have in the oscilloscope to read SPI. Pass type SPI, clock in channel number 1. The channel number 2 is supposed to be to read the data coming from the slave chip. We are not using it in this test. Channel number 2 is the data from the microcontroller to the external chip, master out, slave in. The mode between chip select or timeout, I selected timeout. I did not manage to make it work with channel 3 chip select for some reason. It doesn't matter, because our objective is to make it work with ngscopeclient. Threshold 1 volt and threshold 1 volt over here. By default comes with 0 volts, which is a bit annoying because it doesn't make much sense. Format X, and make sure that we have the bus status on. So with all that, yeah, we can see here the values that the software of the oscilloscope is decoding from the SPI signal using the clock and the stream of data. Those values in X that will be used for later when we use the ngscopeclient to B, C8, DF, and so on. And we press run. Yeah, we can see here how it's doing its job. Cool. So first, we open the application and add the oscilloscope. The client is going to remember our last addition So very easy, you just click here and we are connected to the oscilloscope. It's detecting 3 channels because that's where this Rigol oscilloscope is telling the client where it's detecting a signal, and it's importing the settings we have now in the oscilloscope. So just single click, we don't have much to do. Let's try to capture a bit of data, and yeah, and here we have those 3 channels. All right, so just to keep a bit of to be a bit consistent, if we go to the datasheet where this controller is trying to, the datasheet of the chip that the controller is trying to talk to, we have here a bit of information about how the SPI communication works, the role of the clock, the data that is supposed to go into the synthesizer coming from the microcontroller, and the orders coming from the chip select. So just to keep things consistent, I'm going to use the same names that the datasheet uses. So in the case of clock is SEK, in the case of the data SDI, and chip select. All right, let's organize a bit the flow. We have clock, media, and chip select. So if we bring the SPI decoder, the first thing that we are going to notice is that we cannot connect to it. It's telling us that this decoder is expecting a digital signal. So that's easy to fix with a threshold. We connect the data clock to the threshold, and now yeah, the connection happens. But the threshold in this case is 0 again, not very useful. Let's give it a volt. Another threshold here. Let's give it a volt. This is the data. Another threshold here. And let's give it another volt. So now in the waveform, we see that all those blocks we have been adding is spanning up here, so this gets a bit confusing. Let's move the decoder to the bottom. The threshold 1 under signal 1, threshold 2 under signal 2, and threshold 3 under signal. So zooming in, it seems that our thresholds are making and doing the job is expected from them. You can see the data, the clock coming in, and the threshold reacting accordingly. Data coming in, threshold reacting. But in the case of chip select, there is nothing going on here, and the decoder is also not showing anything. So definitely something is wrong with the signal I mean, not with the signal, I guess our configuration. So in the case of chip select, for some reason, the level of the voltage is much lower. We may need to lower the threshold. Threshold 3, let's give it 200 millis. And the magic is happening. So now the threshold from the chip select is detecting pretty well, and that gives us a chance to the decoder to work. Let's zoom in a bit. You know what? I think I'm going to move this guy up to here. Yeah, I like it better. Or maybe here. Yeah, now. So in this pink color is the action of the chip select. Some EXA values. The decoder knows that at this point it should deselect. Awesome. It waits. The chip select comes again. After a little wait between chip select and clock. So chip select, clock starts, and a bit later comes the data. In this case is to B, D0, DF, and when I tested this earlier, I compare those X values with the values that the decoder in the oscilloscope is giving me, and they match. So I don't want to bother with you with that, but it matches. So the decoder in ngscopeclient is doing its job. Let's see what happens if we try to do a continuous run. Okay. Yeah, we can see some variations here and some variations there, because I think what's happening is that the control is trying to talk with the chip all the time. Obviously it's not successful, so it's kind of repeating a variation of the same patterns again and again and again. Stop. Zoom in. And for reference, this is the diagram of this decoding. Very simple. Clock, data, chip select, threshold. We had to adjust a bit the threshold for chip select, and then all sent to the decoder. Cool. Hope you like it.